The northeast of the U.S., and particularly New England, has had a pretty rough time through September and October with storms. First Hurricane Irene, and then the wet snowstorm event. I believe it was October the 28th, dubbed Snowtober, that did a tremendous amount of damage to trees. And these trees came down and have damaged the electric system. Sarah Sankovich, system arborist with Unitel, contacted me. They are getting ready at her company to go to meetings with the regulator, the governor's office, the attorney general. And the purpose of these meetings, of course, is to look at what could be done better in future events and how do we avoid, as much as possible, the damage in future events. Now, Sarah's indicated to me that the thinking at her company is that their vegetation management program is not really designed to eliminate or avoid outages resulting from such major catastrophic events as these two that I've mentioned, Hurricane Irene and the wet snowstorm. Sarah, I agree. Typically, vegetation management programs, you have a set right-of-way width. You're not increasing that anymore. You're looking for hazard trees. However, because you can't monitor the system, the whole system in real time, there's always a residual population of hazard trees. So they're not eliminated. There is a residual population. So there's some risk associated with that. And the healthy trees, which indeed at most utilities are the primary cause of tree-related outages, aren't targeted by the vegetation management program. And during storms, many times I've heard it said that of the trees that failed, at least 90% were apparently healthy trees. So the vegetation management program is not geared for a major event like what New England has encountered. But what can you do? And Sarah, you had some thoughts and wanted direction who you could talk to, perhaps get what are the reliability gains of various strategies and what are the associated costs. I'll talk a little bit about that. One of the places to go, of course, is the old, to go to the National Grid system, and specifically I'm talking the old Niagara Mohawk system. Ken Finch and Craig Allen some years ago made presentations about some of the work that they had done there, and included was work on subtransmission. I believe it was actually 34 kV lines, where they increased the right-of-way width. And if memory serves, they had a reliability gain in the range of 80 to 90%. So very effective. I don't know what the costs associated were, but it was very effective in terms of reliability gains. Another one I'm aware of is in the aftermath of Tropical Storm Isabel, Pepco was doing some storm hardening. I believe they directed it to specific portions of circuits, for example, between the substation and the first protective device. What I was aware of that they were doing was in areas where they had through pruning, was eliminating all the overhangs. In other words, creating great big V's so that there wasn't any overhang. I don't know the results they had, but I expect that they saw substantial improvements in reliability from that. Again, don't know costs. Back some years ago, we had an ISA meeting in Hartford, Connecticut, and Dave Goodson took us out to some work Northeast Utilities was doing along three-phase lines, and they were doing ground to sky. So there's someone that may have some experience, and particularly, very close to where you are, and it may be particularly interesting to see how did those sorts of lines hold up in the past two storms relative to lines that haven't had the ground to sky clearing. Another one that I have heard of, simply by word of mouth, no direct involvement myself, was that First Energy apparently was doing a considerable amount of work with ground to sky clearing. I want to talk a little bit, Sarah, about the potential available in eliminating overhangs, and then take it a little further out to the ground to sky type thing. Some years ago, I wrote a paper called "Increased Risk of Electric Service Interruption Associated with Tree Branches Overhanging Conductors." You can find that paper, or the links to that paper, at the T&D Vegetation Management site. And in that paper, I provided an example where I looked at what is the change in risk if you had a tree failure and that tree had an overhang versus a tree similar but did not have an overhang. And I provide an example of a tree having an overhang, and then assuming that that branch was pruned back just to the point where the overhang no longer existed, and show that there would be a 22% improvement in reliability on the failure of that type of tree. We can extend that further and say, what if we took that branch not only to the point where it simply cleared the conductor, but all the way back to the bole of the tree? In that case, there would be a 50% improvement in reliability on that tree failure. Now, what that paper doesn't address is the branch failures. And of course, in the wet snowstorm that just struck New England, it's likely that that was the majority of the cause, would have been large branch failures coming down across the conductors. So you need to have, to get a sense of what's possible, you need to have some sort of background data on what typically, what percentage of your tree-related outages are due to branch failures. Let's assume, though, it's 30%. Well, if you were to do ground-to-sky pruning, you have essentially reduced that 30% of your tree related outages to zero. Then you look at, okay, now those pruned trees, what about in the context of their failing under load? By eliminating that branch, you've gotten from 22 up to another up to 50% improvement in reliability. So what this is pointing to is that's an area of great potential for improvements when it comes to future storms. That's something for you to take forward, Sarah, and thank you for raising this and creating this discussion, because I would imagine there are many more like you in New England that are looking at the same sorts of discussions with their regulators and politicians.